Hello everyone. In this session of CCNA series, we'll discuss about one of the most important topics in networking, that is IP address. So what is an IP address? For two devices to communicate, they must be able to find each other. For two devices to find each other, their locations must be known to each other. These locations are identified in the computer world as IP addresses. Every device connected to an internet, for example, computer, tablet, camera, mobile phones, etc. Whatever needs a unique identifier to connect to an internet. In the world of TCP/IP networking, that identifier is the IP address. IP stands for Internet Protocol, which is a set of standard predefined rules used to govern the way data packets are sent over the internet. An IP address, or usually just called an IP, is a series of numbers or a unique address that identifies a device on the internet or a local network. As I said, the IP address basically indicates the location of a device on a network. It allows a system to be recognized by other systems connected via the Internet Protocol. Every device on a network must have a unique IP address for communication purposes. This is similar to an address uniquely identifying a house. Every house is identified by a house number, similar to an IP address, that can be located on a certain street by a street number, similar to a network address. As such, two houses cannot have the same house number. Similarly, two computers cannot have the same IP address on the network. The addresses facilitate the device transmission of message back and forth to each other. If you want to send an email, stream a video online, or receive a document, your device must have an IP address. Without this, the device cannot effectively communicate with or be located by other devices on the internet. There are two primary types of IP address formats used today: ipv4 and ipv6. ipv4 is a 32-bit numeric address written as 4 decimal numbers. These numbers are separated by periods, and each group of the numbers that are separated by periods is called an octet. The number range in each octet is 0 to 255. So the full IP addressing range goes from 0.0.0.0 to 255, 255, 255, or 255. In an octet, the number 0 would be 8 zeros, while the number 255 would be 8 consecutive ones. The maximum numbers the octet can reach. This IPv4 version can produce over 4 billion unique addresses. The IP address shown in decimal format can only be understood by humans. But for computers or network devices, these are meaningless, as they understand only binary format. The binary number of this IP address is the number shown below, which is understood by computer and networking devices. So the question is, how do we get these binary numbers from this IP address? The binary numbering system is a base 2 numbering system, meaning there are only two base numbers, 0 and 1. All other numbers are created from these two numbers. Just like in the decimal numbering system, the location of the number determines its value. The table below shows the value of the first 8 binary positions. IPv4 address is made up of 4 sets of 8 binary bits, and these sets are called as octets. Bits in each octet are represented by a number. So starting from the left, the first bit has a value of 128, then 64, then 32, and so on all the way till 1. Each bit in an octet can either be 0 or 1. If a number is 1, the number that it represents count. If the number is 0, then the number it represents does not count. So by binding the 1 and zeros in the octet, you come up with a range from 0 to 55. So for example, the first octet of this IP address is 172. So how do we get a binary number out of 172? First, look at the octet chart and you would put the ones under the numbers that you would add up to the total of 172. So you would put a 1 in the 8th slot. So now you already have 128 and you need 44 more. Next you add 32, that is in the 6th slot. And the remaining 12 I will add from 4th and 3rd slot to make a total of 172. So if you count all the slots which has 1 underneath them, then you will get the total of 172. Remaining all of the bits will be zeros. We don't need to count them as we already have our number. So this number here is the binary bit version of 172. So let's do the next number down there, which is 16. So you would put a 1 under 16 and remaining zeros that will give you a binary value of 16. So this is how you convert a decimal number to binary form. Let's have a small challenge. I'll be giving you some IP addresses for binary conversion. You can share your results in the comment section. In my next session, I will discuss another important topic on IP addresses about network and host portion of IP address.